So we're in the middle of page 146 here. Now there is a section called the derivatives of the other basic trig functions. So it has the tan, secant, cotan, and cosecant. So let's do the tangent one, okay? So tangent x, the derivative of tangent x is sine x over cosine x. You take the derivative of this. So if we do the quotient rule, we're going to get cosine squared x, low d high, so I take the derivative of this, which will be cosine x, minus high d low. Now I'm going to take the derivative of the cosine x, which is negative sine x. So on the top, I get cosine squared x plus sine squared x over cosine squared x. The numerator is 1 over cosine squared x, so it's going to be equal to secant squared x, okay? So the derivative of tangent x is secant squared x. And by the same token, if you do the secant, you'll find that secant x derivative is nothing more than secant x tan x, okay? So sine x, the derivative of sine x is cosine x. The derivative of cosine x is negative sine x. Then we have tan x, the derivative of tan x is secant squared x. Secant x, the derivative of secant x is secant x tan x. Okay. The derivative of cotangent x and the cosecant x, look it up, okay? I wouldn't go ahead and start memorizing that, okay? But this one and this one you need to know, definitely. So derivative of tan x is secant squared x. Okay, this one, it's on the borderline. It comes up often enough though, okay? Okay, so that is a derivative of the other basic functions, basic trig functions that is. So let's go to example number 4. Let's see if we can do example number 4. Example number 4, we say, find the equation for the lines that are tangent and normal to the graph of that at x equals 2. So f of x is equal to tan x over x. So what are the points? So it goes to a point x equals to 2. So when x equals to 2, y is going to be equal to tangent 2 over 2. Okay. Well, what is tangent at 2, right? So this is a radian. So the radian of 2, when you have a radian of 2, so what's the tangent of that, okay? All right. So let's go. So f prime x is equal to, if you do the quotient rule, x squared low d high, I can take the derivative of this guy, and as we saw it was secant squared x minus high, oops, that's not high, high is tan x d low. So I'm going to take the derivative of the low, I take the derivative of x, I get 1, right? So this is all I got. This is it, okay? So f prime 2 is equal to 4 over 2 secant squared 2 minus tan 2. And the book says if I do this out, I'm going to get 3.433. Okay? So the tangent line is going to be what? The tangent line is going to be y minus this guy. Tan 2 over 2 is equal to 3.433 x minus 2. right? And the normal line is going to be y minus tan 2 over 2, negative 1 over 3.433 x minus 2, right? Because the normal line goes to the same point, this point here, but the slope is going to be a negative reciprocal of the tangent line, right? Okay, so that's that. And now let's see if we can do example number 5. Example number 5, if, find y double prime if y is equal to secant squared x. So y is equal to secant x. So if I take the derivative, I'm going to get what? Secant x tan x. So they want the double derivative. The double derivative is, this is just where to use the product rule, right? Because we have secant x here, we have tan x there. So it's going to be secant x, the derivative of secant x, which is again, secant x tan x, right? That's a derivative of this guy, times this, so it's going to be tan x, plus secant x, then the derivative of tan x, the derivative of tangent x was secant squared x. So I'm going to get secant x tangent squared x plus secant cubed x. So I have 1 here and I have 2 here, so we secant cubed. Okay, and that's it. We're done. Any questions? Are we good?